All right, now let's look at our next graph. Our next graph here has to do with seismic wave speeds. All right, and so we know that there's two different types of seismic waves. All right, we know that we have, number one, surface seismic waves, like the ones in water. And then we know that we have body seismic waves. And there are two types of those. Number one, there is secondary waves that are called S waves. And there are primary waves that we call P waves. And they travel at different speeds. So we're going to look at our chart here, and we're going to look at our body waves, and we're going to look at the speed of them here. All right? So we're going to look at the speed of them. And we're going to look at the different depths down here. And as they travel through the different areas, we have our crust area, we have our mantle, we have our outer core, and we have our inner core. So let's review for a minute about what each is made of. Our crust is a solid, but it's thin. Our mantle is a solid, but more dense. Our inner core is a liquid-like. And our outer core is a liquid-like, I'm sorry. Our inner core is a solid. All right? So this is the P waves, or our primary waves, and our S waves as it travels through the earth, going from the crust to the inner core. So if we go back to our drawing, our thing that we did, it would be traveling from our crust, which is just the top, down to our inner core this way. Right? So this is how we had drawn our inner core. So it's going from the crust here all the way down. So we're taking a look at our P and our S waves and the speed of them. So since we're looking at speed over here, by looking at this map, which ones do you believe to be faster? Your P waves or your S waves? So if our speed goes from 0 to 20, our P waves are definitely the faster of the two. Because our S waves, our maximum speed here is about a little over 7, and our maximum for our P waves is about 19. So there's definitely a difference there. Well, I'm sorry, about 14. Definitely a difference there. So looking at that, we know that our P waves are faster, our S waves are slower. They travel through the crust, and then after they get done with the crust and they get to the mantle, they start to speed up. All right? So both S and P waves speed up when enter mantle. Why is that? Because it's denser. So they speed up when they go into a denser material. So they travel through the mantle, and they keep going faster and faster. And then all of a sudden, they go boom, right around 3,000, and they come to the outer core. And what happens to both of them at the outer core? They decrease quickly. All right? And what happens to our S waves? Goes to 0. All right? So when that happens, drops down, P waves don't go through 0. Then they start to speed up more and more as it gets more dense. So this becomes more dense. All right? So our speed slows in liquid and then speeds when more dense. All right? That's what happens with our P waves. Our S waves, on the other hand, goes right to zero, and they do not travel through liquids. But when we get back to our solid again, they appear. And they come right up and speed up and slow, then level off. All right? So we have they start off, P waves are faster than our S waves. Remember, S waves are slower. They only travel through solids. So SSS. S waves, slower, only travel through solids. And they're called S waves. P waves are faster. They always get there first. They always get there first. P waves can travel through solids, liquids, or gases. When they go into a more dense environment, they speed up. So they are faster in solids than they are in liquids. They slow in liquids. So let's review a few things that we have come up with about this. Our body seismic waves, first one is secondary waves. They are slow, only travel through solids. Our P waves are faster, and they travel through solids, liquids, and air. All right? So since the S waves only travel through solids in our graph here, that's why they disappear here. All right? That is why they then disappear there. They both increase speed when enter a more dense material. Both slow down when they enter a less dense material. Like liquids. All right? So this kind of goes and reviews this graph so that you should be able to look at this graph, review what we've talked about, and then answer questions about it tomorrow. Good luck.